This is rewriting equations and formulas, and today we're going to be looking at literal equations. Literal equations are equations that have two or more variables in them. An example of a literal equation would be 4x minus 4y equals 1, because in this equation, x is a variable and y is a variable, so we have two variables. If you have two or more variables, you have a literal equation. Here we're being asked to solve this equation for y, which means we want y by itself. So our equation is 2y plus 5x equals 6. To get y by itself, I'm first going to get rid of the 5x by subtracting 5x from each side. That leaves me with 2y, and over here I have 6 minus 5x. Now my y is not quite alone yet. I still have a 2 times y. So I'm going to divide each side by 2. And I'm going to simplify a little bit more here. I'm actually going to divide each term by 2. So 6 divided by 2 is going to give me 3 for my first term. And 5x cut in half is going to be 2.5x. This 2.5 could also be written as an improper fraction, 5 over 2. Or I could write it as a mixed number, 2 and 1/2. I could also write it as 2.5. Let's look at a formula that needs to be rewritten. Here we're given the formula for finding the surface area of a cone, and they want us to solve this formula for the slant height. Well, the formula for the surface area of a cone is pi times radius squared plus pi times the radius times slant height. So it's the slant height, or this L-looking, cursive L-looking one, that we want to get by itself. So the first thing I'm going to do is, since I'm adding this piece, I'm just going to subtract this first piece to get rid of it. So I'm going to subtract pi r squared from each side. So here it cancels out, and now I have s minus pi r squared equals pi, excuse me, r times the slant height. The next thing I'm going to do to get the slant height here by itself is divide each side by pi times radius. And these will cancel out. So for my slant height, my formula is the total surface area minus pi r squared divided by pi times r. A formula for converting from Fahrenheit to degrees Celsius is Celsius degrees equals 5/9 times the quantity of Fahrenheit degrees minus 32. Well, what if we wanted to solve the temperature formula for F? So here's our formula. The first thing we want to do is get rid of this 5/9 since it's outside the parentheses. And the easiest way to get rid of a fraction is to multiply it by its reciprocal. So multiply by 9/5. I'm going to do that on both sides. And here it will cancel out. So now I have 9/5 times the degrees Celsius equals F minus 32. So the last thing I'm going to do is add 32 to each side. So I have now 9/5 times the degrees Celsius plus 32 will give me my degrees in Fahrenheit. Now using that formula, 9/5 times degrees Celsius plus 32 equals our degrees Fahrenheit, we're going to try to figure out which here has a greater temperature. The sun, which is 11,000 degrees Fahrenheit, or lightning, which is 30,000 degrees Celsius. So since we're going to convert to Fahrenheit and our sun is already in degrees Fahrenheit, we're going to convert this lightning measurement. So this 30,000 is going to go in for our C, our degrees Celsius. All right, so here I'm being asked to multiply first 9/5 times 30,000, which is really 9/5 times 30,000 over 1. And I could do a little bit of cross reducing here. 5 divided by 5 is 1. 5 goes into 30,000 6,000 times. So 9 times 6,000 is going to give me 54,000. Now I have to add my 32 here, and I get 54,032 degrees Fahrenheit for the lightning. So the one with the greater temperature is by far the lightning. Who knew that lightning had a greater temperature than the sun?